Next part is the frequency. What do you mean by frequency? What do you mean by frequency? Frequency is the rate of change. Frequency is the rate of change with respect to time. Change in a short span of time means high frequency. By high frequency, change over a long span of time means low frequency. If a signal does not change at all, its frequency is zero. If a signal changes instantaneously, its frequency is infinite. Right? Like this is the figure of frequency. Like you can see. The next one is phase. Phase. What do you mean by phase? Phase describes the position of the waveform relative to time zero. So phase means it is the position of the waveform. Right now, if you look at this figure, right, you can see the position of the waveform. Right, this is the phase. Right. The next one is wavelength. Wavelength means another characteristics of signal traveling through a transmission medium. Wavelength means the period of frequency of a simple sine wave to propagation speed of the medium. Right, and this is the figure for the wavelength and period. Then next one is explain the representation of time domain and frequency domain. Also important of this domain, right? What do you mean by time domain? Time domain is the domain in which all the signals are represented. The time domain signal can be tested or verified with the use of oscilloscope. In time domain, signals are represented by amplitude on y-axis and time on x-axis. Frequency domain is useful to do deeper analysis of time domain signals. Frequency domain can study frequency contents of the discrete time domain signal as well as continuous time domain signal. The frequency domain signal can be analyzed with the use of the spectrum analysis. Right. This is the figure for the time domain and frequency domain. Right? The next one is explain the bandwidth of signals and its importance. What do you mean by bandwidth of signals? Bandwidth is the difference between the upper and lower frequencies in a continuous band of frequency. It is typically measured in hertz, and depending on context, many specifically refer to pass bandwidth or base bandwidth. Bandwidth of a channel is the maximum amount of change in a signal channel will allow. For example, if a signal changes too fast, the channel will distort it. For example, when you are looking at a fan which is spinning fast, you don't see the spin of the blood, you see a blur. Your eyes is distorted. This is the figure for bandwidth of signals. Right? Next part is the explain the important parameter of digital signal. Right? A digital signal is a signal that is being used to represent data as a sequence of discrete values. At any given time can only take one of the finite number of values. Digital signal is a sequence of voltage pulses that may be transmitted over wire medium. For example, constant positive voltage level represent binary 1 and constant negative voltage level may represent binary 0. Right? In addition to being represented by analog signal, information can also be represented by a digital signal. For example, one can be encoded as a positive voltage and zero as zero voltage. A digital signal can have more than 2 levels. In this case, we can send more than 1 bit for each level. Right? Here, digital signal terms bit interval. Time bit interval means time required to send a signal bit unit second. Bit rate, number of bits interval per second unit Right? This is the figure for two digital signal, one with the signal level and other with 4 level. Right? This is 4 level. This is the 2 level. This is the 4 level. You can see this figure, right? Part F. The next one is the explain the following related to transmission media. First one is attenuation. What do you mean by attenuation? Attenuation means the loss of energy. When a signal, simple or composite, travels through a medium, it loses some of energy, so overcoming the resistance of the medium, right? This is the attenuation. When this is the original signal, then it is attenuated, then we are getting something different, amplified, right? Noise. The next one is noise. Noise is the another cause of impairment. Several types of noise such as thermal noise, induced noise, crosstalk, and impulse noise. Right? Now you can see noise. This is the transmitted the noise by changing the perceived signal. Distortion. Distortion means that the signal changes its form or shape. Right? It is changing in the form or shape, right, at the center, at the receiver. Now you can look at this figure. It is changing the form, right? The next one is question number 4. Explain the important aspects of digital transmission. Digital transmission is the sending of information over a physical communication media in the form of digital signals. Analog signal must therefore be digitized first before being transmitted. Data transmission is the process of sending digital or analog data over a communication medium to one or more computing networks. Communication of electronic devices. It enables the transfer and communication of devices in a point-to-point to multi-point and multi-point to multi-point environment. Data transmission is also known as the digital transmission or digital communication. To transmit data digitally, it needs to be first converted to digital form. Right? There are several types of conversion, digital to digital conversion. It can be done in two ways: line coding and block coding. For all communication, line coding is necessary, whereas block coding is optional. Right? Line coding. Right? This is the figure for line coding. The process of converting digital data into digital signal is said to be the line coding. Digital data in the found in binary format, it represents the distort internal series of ones and zero, right? Ones and zero. This is the line coding figure, right? Then we can divide the line coding unipolar, polar, and bipolar. Unipolar encoding is to use single voltage level to represent data, right? Then this is the figure for the unipolar. Then polar encoding scheme use multiple voltage level to represent binary values, right? This is the polar encoding, right? Now you can see this figure. Then return to zero RZ. Problem with the NRZ is that receiver cannot encode when a bit ended and when the next bit is started, right? This is the return to zero. Then other things are the ancestor, different ancestor, bipolar. These are some categories of the line code. Then block coding. To ensure the accuracy of the received data frame, redundant bits are used. Block coding is represented by slash notation. NB means, right? The division, substitution, combination, analog to digital conversion. Right, and these are the commonly used method for analog data into the digital form: sampling, quantization, encoding. Right, this is the sampling. This is the quantization. Then this is the encoding. Transmission mode. There are different kinds of transmission mode. This is the parallel transmission. At the same time, it is going, right? Then it is the serial transmission. synchronized transmission. Then those are the 6 and coming another 1.1 machine.